What's up, everybody? This is page 415, and we are talking about properties of kites, all part of activity 4 off of the topic here, and we're talking about properties of quadrilaterals, and in this case, specifically kites. So we are going to launch into question 3. Do you have enough information? Do we have enough information to conclude that KT bisects angle IKE? So that angle is actually created into two angles, top and bottom. Oh, and on the other side, ITE. So this angle is creating three angles, or two angles that are actually equal. Well, yeah, right? If you actually go back to page 414 and look through that proof, we proved that the top triangle, KIT, and the bottom triangle, KET, that they are congruent. Since they're congruent, that means that the angles that correspond have to be congruent by corresponding parts of congruent triangles are congruent. That means if those angles are the same, then there has to be a line that bisects them. KT is that line. What two triangles could you use to prove that IS and ES, that those segments are congruent? So I kind of need this to be a little bit more like over here. There we go. Well, okay, if you look at it, IS and ES are parts of these two triangles. So I'm actually going to highlight them in. I'm going to focus on triangle KIS and focus on triangle KES. It's a kite. So because it's a kite, these two sides are the same. And on those two triangles, they share KS in common. So by the reflexive property, both of those triangles have a side KS in common. And also because it's a kite, KI and KE are the same. And then what we just demonstrated, I was going to say proved, it gets it to prove, but we just demonstrated in question 3 is that those two angles are the same. So in the green triangle, you have a side angle side, and in the orange triangle, you have a side angle side. They're the exact same size. That means the triangles are the same, and for that reason, the sides that we haven't mentioned yet, that's IS and ES, they are congruent by corresponding parts of congruent triangles being congruent. Question 5. If IS is congruent to ES, is that enough information to determine that one diagonal of a kite bisects the other? It's right there in the math that we did. Right there. The thing that's happening is that ES and IS are congruent. Since they are congruent, there has to be something that cuts them in half. That cuts IE in half at point S, and KT is that line. It is the one that does the crossing. All right. Let's prove then that the diagonals of a kite are perpendicular to each other. We've already established all the way back in part 4 that the two triangles, KIS and KES, are congruent. That's these, by the way, right? Those two triangles are congruent. So since they're congruent, they have corresponding parts that are congruent. CPCTC. The two parts that I'm talking about are angle ISK and angle ESK. But ISK and ESK form a linear pair. So because they form a linear pair, they have to add up to 180, but they're the same. But they add to 180, but they're the same. And they add to 180. The only way that's possible for them to be the same and to also add to 180 is if they're both 90 degrees. And if that's true, then the diagonals of a kite are perpendicular. So what does your proof tell you about the classification of a rhombus? Honestly, a rhombus is just a specialized form of kite. A rhombus is what you get when you intersect or blend the properties of a parallelogram and a kite together. In a parallelogram, opposite sides are congruent. Opposite angles are congruent. Diagonals bisect each other. And in a kite, the adjacent sides are congruent, and the diagonals are perpendicular to each other, and opposite angles are congruent. A rhombus is a specialized type of kite. It just has a few more specific rules from parallelograms, mind you, that it also has to follow. This has been Properties of Kites for page 415. A little sneak peek at what's next is using those properties to solve problems. We want to get into how we can use properties of parallelograms and quadrilaterals to solve problems to make this whole proof section and deep thinking relevant in a hands-on approach. So thank you for watching this video. Thank you for getting your notes taken care of and getting that done. I will see you in the next video. Page 416 is next. See you later. Bye.